Today you'll be learning about function operations and composition of functions. But first, let's start with the riddle. What weighs more, 100 pounds of rocks or 100 pounds of feathers? Which is heavier, 100 pounds of rocks or 100 pounds of feathers? Neither one, they both weigh the same. They're both 100 pounds. Haha. Okay, that's not that funny, but whatever. Okay, first of all, I want to make sure you understand function notation. We're used to functions looking like this, where if I say, what is y when x is 3, you would simply plug in 3 for x, and you'd get y equals 7. Well, this is a different way of writing it, where we just ask what is f of 3. It's saying the same thing. Instead of x, we're going to replace the x with a 3. This is just a different way of looking at it. The answer is still 7. So notice this is x and now this is y. Or you can look here where y is, we now, where y was, we now put f of x. So these are equivalent. And the ordered pair that results is x, y. Let's jump right into an example and make sure you understand how to evaluate for a given number. If I ask you to evaluate h of -2, then you find the function with the h, and you're going to plug in -2 for every x. So this would simply be 2, and put the -2 in place of the x, but I still need to put the square on here. You could use a calculator or rely on order of operations. Exponents go first. -2 times -2 is 4, so you get 8. If I ask you to evaluate f of 3, you find the f function, and now you're going to plug 3 in for x. With order of operations, multiplication comes first. So our answer would be -7. G of -1, we find the function with the g. We plug -1 right there for x. And if you use your calculator, which you probably don't want to for that one, you get -6. Example 2. Is -3, 2 a point on the graph of each of these? Well, first of all, if I graph this, I would get a line. What I want you to understand is that this is simply x and y, and if you plug in the 2 for y and the -3 for x, you're just asking, will you get a true statement? So I'm going to plug 2 in for the y, and I'm writing everything else the same. Where x is, I get -3. And if I simplify this, I'm saying, does 2 equal this side right here? So if I do this, I get -6 plus 8, and that equals 2. So that means that this point is on this line. And if we were to actually graph it, let's recall graphing. If I go here and start at 8 on the y-axis, and I do a rise of 2 and a run of 1, guess what? This point, back 3 up 2, is going to fall on that line. But we don't have to graph. We can simply plug in the x and see if it equals the y. So if I plug in y as 2, and negative 3 for my x, I'm asking, is this true? It's kind of how we used to do a double check. So that's 6 minus 4 is 2. And to answer the question, yes, that's a point on the line. For part A, yes, negative 3, 2 is on this line, as well as this one. Let's see it. Oh, look here. Instead of y, we have a f of x. But the first thing I like doing is rewriting that with a y. I like to see my x and y. And now I'm going to substitute y is 2 and negative 3 in for x. So what's the absolute value of negative 2? You just make it positive. So this is definitely a true statement. And again, that point would fall on this graph. Don't forget, this graph looks like an absolute value. It is an absolute value. It looks like a V when you graph it. Let's see if, what was it? Negative 3, 2 falls on this parabola. 2 substitutes for y, negative 3 for x. So negative 1 squared plus 1 up 1 plus 1 is indeed 2. So this one checks as well, and yes, that point again falls on the line. Now, let's talk a little bit about function operations. Here, we have our same 3 functions, but now I want to show you how to add functions. So what this actually means is f of x plus g of x. And now we can write those functions. F of x equals this, and g of x equals this. Now combine like terms. That's negative 2x when I combine them. Remember that coefficient is a 1. And now when I add the constant terms, that's negative 3. So that's my final answer right there. I'm just combining like terms. If there were fractions, I would reduce them. And that's all. And honest and true, I really just simplified. I wasn't able to evaluate because I don't know what number represents x. So another one where I'm just going to simplify. G minus f of x means g of x minus f of x. I wanted you to see subtraction because we have to be careful. G is up here. That's x minus 5. And f is negative 3x plus 2. And since it's subtraction, I have to be careful because I'm going to distribute the negative to both parts of f. So I get x minus 5. Negative times a negative is a positive, and that's minus 2. So we get 4x minus 7. And remember, when things go too fast on the video, just pause, go back if you need to. So g minus f of x equals 4x minus 7. Now, what was h? Oh, 2x plus 2. So this is really h of x times g of x. So I'm going to multiply these functions together. So h of x is 2x squared. And let me see what g of x is x minus 5. In this situation, I'm going to take this and distribute it to the x. So I get 2x to the third. We add exponents. And now I'm going to take the 2x squared and distribute it to the minus 5. So 2 times negative 5, that's a minus 10. And I still have my x squared. So notice when we multiply numbers with numbers, variables with variables. Now, this one we can actually evaluate because it's not an x. We have a 4. So 3 times an f of x was negative 3x plus 2. But notice, instead of x, we're going to put 4. So we actually know this time that x is 4. So I can substitute that in, and I get 3 out here. This is negative 12 plus 2. Look at that. I was able to actually see what it equals because we know that x is 4. And now I'm still doing what's inside parentheses first. That gives me negative 10. This might look like subtraction, but this is multiplication because of the parentheses. Negative 30. Here's our last example. I want to teach you about composition of functions. This is a small open circle. This is not multiplication. Not multiplication. This is putting the second function inside the first function. And I'll show you what I mean. We're going to, and notice we're using our same 3 functions that we've been using all lesson. G composite f of x means g of f of x. So now I'm going to write what f of x actually is. Now be careful. I'm going to substitute into g now. So I started by putting what f of x is right there. And now that there's a g, that means I'm going to the function with the g, and I'm going to put all of this in place of x. So now I have negative 3x plus 2. I'm right here. And now I'm going to subtract the 5. And now I need to combine like terms. So I have negative 3x, positive 2, and a negative 5 is minus 3. Final answer. I'm just simplifying. Now, I want h of f of x. The second one always goes inside. So, f of x is a negative 3x plus 2. And now I'm going to take that and put it inside for x. So we get 2 times negative 3x plus 2 squared. See, we got that square right there. We got the 2 in the front. Now, I want you to remember that you cannot distribute the square. You actually have to write that twice. And now I'm going to take this negative 3x and distribute it to both parts. I'm going to leave the 2 out front. So negative 3x times a negative 3x is a positive 9x squared. Again, I'm taking this and I'm distributing it to the 2. I get a negative 6x. Now I have to take the positive 2 and distribute to both. So that gives me a negative 6x when I go here. And when I go over here, gives me a positive 4. I'm going to combine like terms. And now I'm going to distribute the 2 to all 3 parts. In another lesson, I'll review how to distribute when you have that square and you end up with 2 binomials. We'll review that a little more. Let's finish this one. Okay, so this equals this. I'd like to do one more with you. Let's use the same functions. Let's say we have f of g of 2. So what you would do here is put the g of 2 inside. But first, let's just find out what g of 2 is. So now I'm going to go up. G of 2, I just plug 2 in for x. So that would be g of 2 would just be, what was that, x minus 2? No, x minus 5. So instead of putting the 2, I'm going to put the 2 in here, and g of 2 equals negative 3. And now I can easily put the negative 3 here. And now I can see what the f function was. F says negative 3 plus 2. But instead of x, I'm going to put the negative 3 in here. So I get 9 plus 2 is 11. So all of this just equals 11.